my career, I wanted to be a pediatrician. I thought I was going to be helping sick kids. But I realized that if I was dealing with kids that were chronically ill or suffered from various types of genetic diseases and conditions that traditional medicine really didn't have an answer for, then I would be frustrated by that. And I would either have to emotionally wall myself off, or I would just become desensitized to it over time. And I didn't want that to happen. So rather, what we decided to do was we were going to build a company that was committed to developing breakthrough types of medicine that traditional approaches just simply don't have an answer for. Conditions where you can't just give somebody a pill and magically make them better.
When I get asked, oh, what do you do? And I say I do stem cell research, the very first thing that I have to tell people is I don't work with embryonic stem cells. I work with adult stem cells because I've often seen how they pull away from me or they treat me as I'm some sort of baby killer. Adult stem cells are cells that are derived from tissues in the adult body, from bone marrow, from fat, umbilical cord blood.
The interesting thing about these cells is that we can administer them like type O blood, so we don't have to tissue match the original donor or the patients that we're putting them into. They'll actually home to sites of tissue damage and inflammation and injury. So when we administer them intravenously, the cells will actually figure out where the problems are, they'll migrate to where the damage is, and then when they get there, they'll actually do multiple things in concert to try and promote or accelerate healing and tissue repair.
What we've seen to date is if you take the cells and you treat rats after they've had a stroke, you end up saving up to 50% of the brain tissue that they would lose if they weren't treated or if they were treated with placebo. And that leads to a direct benefit in outcome measures, doing things like locomotor testing, neurological testing. And they also get better faster as well.
Nerve cells, they kind of look like my arm here, where you've got the body of the nerve cell and then you've got the things that extend out from the end of the nerve. When damage occurs, there's signals that get sent that actually cause the neurons to physically pull back from the region of damage and injury. If we administer multi-stem, the stem cells will actually talk to the nerve cells and actually causes them to grow back in the right direction so they can try and reconnect with what's on the other side. These cells are literally helping the body fix itself by reducing inflammatory damage and by promoting the healing response and accelerating it in some very powerful ways.
We're currently looking at using the cells in obviously acute stroke, traumatic brain injury, heart attack, spinal cord injury, Gehrig's disease, multiple sclerosis, Tay-Sachs, Parkinson's disease, Charcot-Marie, Huntington's, congestive heart failure, inflammatory bowel disease, prophylaxis of some cancers.